Okay, well, thanks, Tom. Good afternoon. The purpose of this presentation is to provide a brief overview of the department's new policy for coatings of structural steel bridges. The Structures Bulletin C-1202 was issued in February of this year. And the bulletin not only establishes requirements for the use of uncoated weathering steel, but it also implements a new policy for all coating systems for steel eye girders and tub girder bridges. Per the new policy, uncoated weathering steel is to be used on all eye girder and box girder bridges if the environmental conditions allow or are suitable. If the use of uncoated weathering steel is not applicable, an inorganic zinc coating system is to be specified. Where aesthetics or other considerations warrant a high-performance coating system can be specified, but only with written approval from the chief engineer. The decision as to which type of system to use needs to be made early in the BDR phase or prior to the issuance of an RFP for design-build projects. At this time, these provisions aren't applicable to either bascule or pedestrian bridges. Implementation of the new policy required modifications to a number of FDOT documents, including the Plans Preparation Manual, the Structures Design Guidelines, the Structures Detailing Manual, and all of these revisions are included in the design bulletin, but will be included in the 2013 edition of these documents. There were also revisions made to the standard specifications, and those were added to the January 2012 workbook. The use of uncoated weathering steel is applicable to sites with certain environmental constraints. Those constraints are described in revisions to Section 1.3 of the Structures Design Guidelines. The use of uncoated weathering steel is to be specified where the superstructure is slightly aggressive in accordance with Section 1.3 of the Design Guidelines. The time of wetness is less than 60%, and the bridge must be located at least 4 miles away from the coast. If it's located within 4 miles of the coast, then the maximum airborne salts and the average SO2 content need to meet the requirements shown here. They need to be less than the values here. Also, the minimum vertical clearance over normal high water or mean high water must be at least 12 feet. For information with regard to the time of wetness or the airborne salt deposition rates and average SOT at a project site, the engineer should contact the State Materials Office. Mario Paredes is the state corrosion engineer. There's his contact information. He is the person that will have this information. Okay. The current specifications provide a default color for the Class 5 concrete finish. Now, in order or along with this policy for weathering steel, we've also added a designated default color for the Class 5 finish to go with uncoated weathering steel. This right here is from the Structures Design Guidelines, and basically it specifies the default color, which was a standard concrete gray to be used on all bridges, and now we've added a new color, this 36642, for uncoated weathering steel bridges. If you're going to use other than those two colors, you need to specify in the plans, but the specifications will automatically designate the 36642 for uncoated weathering steel. This is a sample of what the current Classifier Finish looks like, and this would be the color roughly of the new Classifier Finish to go along with the weathering steel, so kind of a beige. We've also added new painting notes to be added to the plans. They've been added in section 5.3 of the Structures Detailing Manual. There are basically 6 painting options, and they include uncoated weathering steel throughout the structure, uncoated weathering steel with the exception that the outside face of the exterior girders are to be coated with an inorganic zinc compound, uncoated weathering steel with the outside face of exterior girders coated with a high-performance coating system, inorganic zinc coating system throughout. Again, inorganic inorganic zinc coating system, except that the outside of the exterior girders would be coated with high-performance coating system, or in the final, if aesthetics warrant, paint all the steel with a high-performance coating system. Now, again, the use of the high-performance, the default treatment for bridges is always going to be uncoated weathering steel, and any use of the high-performance coating system will require approval by the chief engineer. We've also added new details to the Structures Detailing Manual to reduce the potential for deterioration of the uncoated weathering steel due to runoff, as well as to reduce the potential for staining of substructure elements. New details for uncoated weathering steel include the requirement for drip tabs on all bottom flanges to divert the runoff from the superstructure, drip strips along the outside edges of the exterior eye girders to channel runoff water past the pier or vents or to the pier or vent troughs adjacent to girder ends, and we'll see, I'll show some details of these. And sloping the caps at all indents and at piers located at intermediate deck joints, so that we prevent any water that runs off of the girder onto the vent cap to run down the face of the cap. And we will provide troughs in the troughs and some means of drainage in the caps to get the water away. We've also added the requirement for a sacrificial end plate to be welded to the ends of eye girders. The purpose of this plate is to prevent water from leaky joints to fall on girder flanges. We also call for the use of sealed expansion joints, and we need to avoid any details that cause water to pond or retain debris. As was the previous case for painted steel boxes, the interiors of uncoated steel boxes are to be painted for inspection. Additionally, what we've required is the outside face of the end diaphragms and to be painted, because this is a location where debris would settle on the stiffeners, and or you'll have pigeons and whatever roosting. So we want to protect the exterior of the end diaphragms on these boxes. These are the details that are included in the bulletin. You can see that the details for steel eye girders were included in the design or the detailing manual in figures 16.12-1 and 1612-2. Some of the things that you can see here, and I know this is kind of small, but we have drip tabs that are underneath on the top and the bottom of all the flanges to be placed upgrade from the bent, and we give you a distance there, and these are just small bars that are welded to cause any water running down the flange to fall off. And then underneath we also have drip tabs. In addition, we're providing what we call a drip bar that runs along the outside edge of the bottom flange of the exterior girder, and the exterior girder only. And the purpose of this is to channel any water or moisture that gets on that beam, gets channeled all the way down to the end of the beam, where then it could fall and run off onto the top of the cap and into the trough. In the case of where you have a continuous girder, this flange drip bar will start again upstream or upgrade from the pier and run down. What we do is we'll turn it in so that any moisture running through or any runoff running through will actually run up underneath the clip and then run past the pier, and then it will be able to drip down away from the pier. Obviously, the reason for this is all to keep this water from falling off the bottom flanges or running down the girder and then staining the face of the substructure. We're also providing at the ends of these girders a 1/2 inch sacrificial plate. We're sloping the indent caps and sloping the pier caps to a trough. We're providing a drainage pipe to take that water from that trough off of the bridge. And then for box girders, we have figure 6.12-3 for the box girders, and basically it has the same requirements, with the exception we don't have that flange drip bar. we do have, though, a drip tabs, even as small as they might be, on the bottom. We also have the same requirement for the slope cap and for the pipe.